Boa tarde a todos vocês, bem-vindos a mais uma sessão nossa do Maker Day Brasil 2021, Green Edition. Boa tarde, irmão Wander, tudo bom?
Boa tarde, Soralina. Boa tarde, Daniela. Muito legal, a gente está começando a nossa segunda sessão, como disse Soraya, Green Edition, aqui para o Maker Day Brasil. Se você não conhece o Maker Day Brasil, este evento está acontecendo em 24 cidades no Brasil, em American Space, em centros binacionais. É a quarta edição, então se você não conhecia, se prepare, porque a gente estamos na quarta edição, entrando já para o calendário nacional de um evento aberto, gratuito, que explora a curiosidade, que explora o trabalho colaborativo. Enfim, Dani, boa tarde para você, rainha.
Dani, você está mutada.
Cadê, amiga?
Oh, meu Deus, até hoje não aprende. Gente, boa tarde. Feliz demais de estar aqui com vocês, apresentando aqui a nossa super facilitadora da tarde, hein, Wanda? Quem vai estar com a gente?
Tem uma surpresa aí hoje, né? Mas deixa eu só falar uma coisinha assim, ó. Maker Day é fruto de um movimento aí de 24 centros binacionais espalhados pelo Brasil, numa ação simultânea, está todo mundo rodando evento hoje. Depois vocês deem uma olhadinha no site do Maker Day Brasil para ver outras sessões, em parceria com o apoio da Embaixada Americana, da Embaixada dos Estados Unidos aqui no Brasil. E a gente teve um convidado muito especial hoje de manhã, foi o Natan Rabinovich. Beijo, Natan, obrigada por ter se juntado a nós. E agora temos outro convidado muito especial, né, amiga? Amiga, eu queria que você apresentasse esse convidado especial de hoje à tarde. Porque, assim, é muito fruto, né, das suas intenções aí, né?
Sora, obrigada, é um prazer. A Jasmine, ela é uma ilustradora, uma mulher da área de STEAM. Ela faz assim projetos maravilhosos no Twitter, né, na comunidade Twitter, agitou todos os makers enclausurados em 2020, querendo achar amigos para brincar, e foi assim que eu achei a Jasmine, cheguei até o website dela, me apaixonei pelas ilustrações, pelo livro que ela ainda vai lançar, e já vai dar aí uma palhinha para a gente, e sem mais delongas, né, com vocês,
Welcome, Jasmine.
Jasmine Florentine. Com você, querida. With you, Jasmine.
Welcome.
I understood that part. So, should I get started? Or
yes,
okay. Take the stage.
So, yeah, I mean, as for those of you who already understood the Portuguese, I'm Jasmine Florentine. I'm a mechanical engineer, illustrator, and author, and like more than anything, I guess I'm just a maker, and I really enjoy STEM and getting kids and just people in general excited about STEM. Yeah, let me just, I guess, introduce a little bit about, I'll share screen to show some of the stuff. I think some of you already know me and have probably seen some of this. Actually, before I share screen, let me just mention one more thing. So normally I'm living in Israel, which is where all of my projects are currently sitting. And so I would love to have been able to show you all the projects in person, but I'm currently in the US and there is no way a bunch of paper robots and cardboard things were going to survive the plane ride without getting squashed. So let's start. So I cheated for the about me. I literally just put a link to my website. But yeah, like I said, so my background is in mechanical engineering. And I've always really loved combining art with engineering. So like a lot of the stuff I have worked on has tended to be kind of in this intersection of like technology, but also making things look nice. And I worked for a while at First Robotics, which for those of you who don't know, but are interested in robotics, is a student competition that gets them interested in robots and engineering and all that. And while I was there, I was building I was helping build the fields and got to do all kinds of like artistic things along with the engineering, which for me is really fun. I also mentioned that I'm an illustrator, so I do a lot of drawing just for fun and now more recently for books as well. And the other thing is more recently, I wrote a book, which the bad news is, so I can't, first of all, I should mention the cover art here, the beautiful cover art. It's not done by me, it's done by another illustrator, Ebony Glenn, who's really amazing. This book was unfortunately postponed because of COVID, so it won't be coming out for another year. But part of the reason I started writing is because I wanted to find a way to use stories to get kids interested in engineering. And so the kinds of stories that I tell, this book and future projects that I can't talk about yet, generally are all about kind of making the characters build cool things in the context of a story. And so I'm very much a huge fan of like combining STEM and tinkering and stories. And then the one other thing is just I've been doing, especially over lockdown, I started playing a lot with paper robots. And that was just because I didn't have access to Machine Shop or 3D printer or Makerspace. And also a lot of other people don't either. So I kind of wanted to show that there's lots of things you can do that don't need to be using like really high tech tools. So let me stop the share for a moment, or do I want to stop the share? Sorry, I put together this presentation. Yeah, so I'll stop for a moment just so I can, oh, right, I can't actually see you guys because the cameras are all off. It was very strange. So in terms of stories, I wanted to kind of wrap back to that because that's a big part of what I do. And there's really like, I guess the first thing is there's no like right or wrong way to combine stories and STEM. Like I've seen people do it in all kinds of amazing ways. So what I'm describing is just sort of my personal approach. And so I think of it as kind of two different things. One is using projects as a part of the story. So like with the book I wrote and upcoming projects, it's more like you've got narrative. I will go back to sharing screen. Sorry that I keep swapping back and forth there. So something like this, which is just a screenshot where you've got a story and the characters are building projects as part of that story. So in this case, it's just a little snapshot of a character who's made a booby trap using like a microbit and touch sensing and stuff like that. And the other approach I like to use for stories is also using, so if this is using projects as part of the stories, there's also using the project to tell the story itself. And so a lot of like the paper robot stuff that I do tends to be very, very simple stories. Like, you know, they're not very, I'm not, you know, it's not like a book where you've got a once upon a time and a middle and a happy ending. It's just, you know, in this case, it's a very simple story of like, there's this little robot and if you tickle his foot, he like starts to wave his hands. Or, you know, this little octopus is telling a story as well. And so the thing is about this, the story element is like, stories are also kind of, it's a very open term, right? So in some ways, just the act of transforming like, you know, paper and like, you know, straws and a motor into a character is already telling a story. The story that we're trying to tell, for instance, with the bicycle that I posted to Twitter, for anybody who hasn't seen that, the story I'm telling here is just that this is, put that real quick. So I'll get more back to like the specifics of how I made that and the mechanism. But I guess what I'm trying to say is even that, it's not a story in the traditional sense of like, it's not a character or something, but it's still a story in the sense that I'm trying to convince you or anybody watching this, that this isn't just a collection of cardboard and sticks and paper, that this is actually a bicycle. And so I think that the term story is going to be very broad in the way I use it. So the other thing is I mentioned that I'm a mechanical engineer and that I try to bring a lot of that into my projects. So I tend to think a lot about mechanisms. And one thing I especially like doing is thinking about how I can take traditional engineering mechanisms like, gears and motors and things like that, and how I can adapt them into materials I have at home, like cardboard and like paper. And a lot of the time I'm thinking around mechanisms sort of both like in a backwards and a forwards way. So for instance, with the figure skater I have here on the far right, I started that by saying, I want to make a figure skater. And this was actually for a Twitter challenge that was doing the microbit virtual Olympics, which is really cool. And I know it's the Summer Olympics, but figure skating is my favorite Olympic sport. So I went with that. So I had this idea first of this is the story I want to tell. And then based on that, figured out what is the mechanism I want to use to tell that story. And based on that, figured out like how I'm going to actually build it. But then sometimes I'll also go the other way. Sometimes like with this octopus, I started with, I really want to make an octopus, not an octopus. I really want to make something that uses a motor to make 8 or multiple pieces of paper move at once. Because with the Ticklebot, you've got like one arm and one motor and it waves around. And with this, you've got, if I go to the, you've got 8 tentacles all moving together. I think it will show the, so I actually started with just this idea of I want to move multiple pieces of paper or something together. And based on that said, oh, maybe I'll make an octopus. Octopuses have 8 legs. And then from there it was sort of like, okay, so what is the story I'm trying to tell with this octopus? Why is this octopus pulling their tentacles in? Maybe they're shy or maybe they're angry. And then kind of based on that, use that to figure out like, what is the input I'm going to use? So I decided to go with noise. Like this is an octopus who doesn't like loud noises. And that's why he's pulling in his tentacles. And now I get to use the mechanism that I want. And then giving it a face kind of just plays into that story. He's angry because he doesn't like loud noises. So that's kind of like my thinking when it comes to stories. And as you can kind of tell, I'm, the way I'm talking is a little bit all over the place because the way I think about stories is a little bit all over the place. Because I just think there's so many different approaches from like just making a very simple character to telling a longer story to just using the projects as part of a story. So yeah, so for this workshop, the focus, as we know, is green energy. And I decided specifically to focus on wind power because it's a fun way to make things move that doesn't require any electronics. And it's something that people have already done in really incredible ways. So at kind of the extreme end of like an incredible use of wind, for those of you who haven't seen The Strand Beast by Theo Jansen. So this is, yeah, they're all wind powered. Don't ask me exactly how it works because even I'm not sure. Just let that think for a second. So yeah, so that's sort of an extreme end of how you can use wind to tell a story. And again, the story here is that there's this creature that's really just powered by wind and made of wood and other materials, but we look at it and we see something alive because it's moving and it's moving in a very natural way. Another thing that, funny enough, I suggested using wind without even realizing that whirligigs are a whole thing. And so whirligigs are specifically installations and projects people make using wind power. So here's just another example I found while I was researching for this workshop and thought it was, oh, whoops, this is actually, I think I put the wrong YouTube link because there was one where it shows it working. There we go. And so there's this whole little story here just being told with wind. And again, these are incredible because they are very complicated. But the thing is, you can also tell much simpler stories, something you can put together in just a little bit. So Danny, I'm actually sharing yours, which was inspired by the Exploratorium. The Exploratorium has a page. I'll have a link for it at the end. And this is a much simpler whirligig, but it's still like this character spinning this thing, and it tells this story. So I started, when I proposed the workshop, I started experimenting myself and like very much wanted to try different mechanisms and see what were the kinds of stories I could tell. Like I said, I don't actually have a lot of the stuff I built with me because I had to leave it in Israel. So I took a lot of photos and videos and built a couple more things once I arrived here. By the way, I also realized that I haven't been looking at questions or anything. So Danny or Soraya or someone, if you need to interrupt me to let me know if there's a question.
Okay, anytime we have a question from the YouTube, please guys, if you have a question, write it down on the chat box at YouTube. The guys that are here with us in the Zoom room, also you can write it down at the chat box, a question, and we can pass it on to Jasmine, okay?
Yeah, just I have like two screens open, and if I open up the chat,
it's okay. People are saying like, wow, I want to do the tinkle.
This is so cute. I love the whale.
Yeah, so yes, the crowd pleaser.
When you can't see anybody's face,
feel reassured. We just love everything, and we are tinkering along, right? So if you guys at home have materials and feel like studying,
you can write your question in English or in Portuguese, okay? No problem.
Okay.
Fantastic. That's great. Thank you. It's so weird when it's like you don't see.
We got you covered, Jasmine.
So I started also just tinkering and exploring things, and I was just doing. I started with some very straightforward things. So like this is my first version of a bicycle. Before I decided to buy a fan, it only has one wheel moving, and that's because at this point I still hadn't quite figured out like what mechanisms I could use, and just wanted to figure out basically like, can I make moving pictures? Then I started experimenting with more mechanisms, and a lot of the challenge is sort of trying to make gears and stuff with just materials I have at home. So those are just made of cardboard and glue. And then, like I said, I'm a mechanical engineer, so I'm gonna go a little bit into the mechanisms, but like, you don't have to do any mechanisms like this. You can still tell really simple stories. And what I'll do is I'll go through this and then we'll talk about how to actually make this for anybody who wants to walk through. But so I experimented some more with making gears.
Jasmine, sorry to interrupt, but we do have a question. Tonya would like to know if, Jasmine, do you sketch out your designs first?
Yeah, that's a good question. So I sometimes do. So here we go. So actually I did a couple of sketches here, and they're very, very loose sketches. So like I had an idea for like a boat thing, which I didn't make, and I was figuring out the base, or here just like making sure I knew the directions the gears were. In some ways, the things that I built, and I did actually sketch this frog guy I also sketched. I don't remember where I put, I do remember where I put the sketch. It's in another room, but yeah, I do sketch things at first. And then what I also do is I treat sort of the first prototypes in some ways are sketches as well. So like this, this bicycle is eventually what became like this much fancier looking bicycle. But I sort of used the first one as it's more like a three-dimensional working sketch. You can see I just drew it with, Sharpie, like right on there. So I find it's really helpful. Yeah. And and similarly, even when I'm like experimenting with all these things, like in some ways it's sort of like it's a way of sketching as well. Like I think I did sketch these out on paper, and then I was just like, let's just start putting some tape together and see what happens. So these are actually the second round of gears that I tried, because I was trying to avoid hot glue, just because I sort of, not everybody has a hot glue gun. Also, if you're working with kids, sometimes, well, I was gonna say, if you're working with kids, sometimes they burn themselves, but I also burn myself. So, so these gears are just barbecue skewers that I just cut up and basically poked them through the holes here, and then put a drop of glue on them and let them dry for a few hours. And they mesh with, so there's gears that have the pegs coming out this way, and then gears that have them flat. And for those ones, I just taped them right on. And so the reason I did that is just so that they can mesh with each other. This one, I think it was before I actually measured the diameters, which was silly of me. So like these don't actually mesh. But the later ones, again, it's also, making things up as I go along.
You have convinced Helen. She said it's brilliant, and she's very excited to try with her own students. And so am I.
Me too.
Awesome. Oh, I want to see what they make. Yeah. And so just, again, bear with me while I like geek out as a mechanical engineer for another moment here.
Okay.
I'll go back to the fun stuff. For anyone interested, so like the way gears work is they're used for a couple different things, but they're used, for instance, you can take a small gear which will move fast but not have much torque or like power, and use that to spin a bigger gear. Here, a lot of the times I was doing it actually just to make multiple things move at once. So the big thing that I, did was, so a couple of things is one, gear ratios. I won't go into too much, but like basically it's just something you need to keep in mind when you're designing the gears, is making sure that like, if you want the gears to mesh, that the diameter relates to the number of the spokes on there. For the bicycle, the number of gears on there, or the number of teeth on there is actually the same. It's just 8 and 8. And that's because it's being used so that I can take one spinning motion, which is the pinwheel, and then using that to make 3 different moving parts, or 2 in the case of the bicycle. It was meant to be 3, but I didn't get to finish the rider. So, and like I said, to some degree, the way I'm thinking about these things is I'm thinking about when I said I'm going to use wind, I was sort of thinking about, if this was a motor, how would I use it? And so I'm kind of thinking the entire time of like, I'm just going to treat this pinwheel as a substitute for a motor. And that kind of helped get me thinking like, okay, what are the kinds of things I can do with a motor? Well, I can attach gears to a motor. Why can't I attach gears to the pinwheel? So in this case, it's 8 and 8 teeth, and just basically one is flat and one is through, and just the diameter of it is roughly the same, so that the spokes mesh together with the ones on the other side. So the diameter, not the cardboard, but the outside diameter, the gray line there. And I can answer more questions about that when we actually get to the tinkering part. So like I said, I experimented with that, and that is how I made that bicycle model. I think that's the same video, isn't it? Yeah. Oh, this was, so just to give you a sense of how I experiment as well, is I don't magically, put the whole thing together in one go. I'm experimenting as I go along as well. And so you can kind of see there before I gave up and eventually bought a fan like this because I was running out of breath.
I bet.
But yeah. Yeah, so like I'll just kind of try it as I go along and see what works and see what doesn't. So, was building the bicycle, and you can see that it's got it's probably easiest to see what's going on from this perspective, where it's got the 3 gears in the back and the bicycle in the front. And like I said, there's actually 3 moving parts. So in the video, I only used 2, which is the bicycle wheels. Where did my frog go? This frog was supposed to be the rider. But unfortunately, the bicycle's in Israel and the frog is with me in Washington, D.C. So you'll have to pretend for a moment, but.
Okay, this is so cute.
So he would have been pedaling the bicycle. But
when he flies back to Israel, he can go bike riding.
I might have to make him again because I don't think he's going to say that. And this is also just, again, experimenting with different ways I can use all these things. So here, I'll stop the share for a moment so you can see the frog bigger, I guess. So the frog is actually just 1 pinwheel. Yeah, and that's fun. So, and again, on the bicycle, it would have been the center pinwheel, whereas the other 2 are the wheels.
Yeah.
And then the movement is it's just this cardboard circle going around attached to the pinwheel. And I've got I've been using bent paper clips or straightened out paper clips to just kind of stick things through. And so the foot is just attached to there, and then the leg is just a hinge, again, made out of just more bent paper clips. So you can create all these like different movements just from the one spinning motion. And then even just, actually, let me go back to share screen because I wanted to share the exploratory.
So the frog mechanism is easier because it's only 1 wheel. You just have to make the articulation in the character, the frog or another character you want to. So you have to think about the articulation, but you only use 1 wheel attached to the pinwheel, isn't it?
Yeah. So the frog took me much less time. The gears took forever.
So maybe it's a good project to start with the
wind power.
The wind power moving wheels with your students. And then you go and add difficult as layers and go to the gears and so on.
Start scaffolding a little bit. Awesome. I think I'm gonna go for that.
You don't even need to start with like the reason I showed the bicycle first is just because that's how I started to explore it. But because I wanted to see how much can you push it. But you don't even, I think one thing I didn't take a video of because it didn't come out great, I probably should have just taken a video anyway, is, this already, it has articulated mechanisms, but you can even make it simpler. Like, what if I just take the frog off and I put a picture on here, and then when I blow on this or glue, something, then this is going to be spinning too. And so you can already just do something very simple. I think I tried making like a pig that was like jumping over a cloud, or the cow jumping over the moon or something. So you can start very simple. And the other thing was I looked at also kind of what Danny and the Exploratorium were doing. Is another approach is to use a crank. So this is just a pinwheel attached to a bent paper clip again, and it acts like a crank. This was originally going to be an elephant where the trunk moved, but the elephant is very tiny. So instead of an elephant squirting water.
I love it. I love it. So cute. Paper. It's a paper elephant, right?
Yeah, it's just origami.
Yes, origami.
Yeah, origami, light materials. They are wonderful for this kind of project. Awesome.
Yeah, and this mechanism inspired by from Exploratorium, it's amazing because you are turning the pinwheel and the scene actually gives you an impression that it's the other way around. It's the elephant that turning the The cracking?
crane.
Yeah, look at that.
Yeah.
How cute. And it's from, they got inspired by an Israeli artist, I think, Jasmine.
Yes.
Yeah, Noga.
Yes.
I would like to meet her. I have
Me
to meet her.
too. I checked this link, awesome things she does. Beautiful.
Yeah, so that was one of the things I was going to mention is everybody should also check out their website, and the way they built the pinwheel is a little different than I did, but it all worked. Like, it's still a pinwheel.
Yes.
And the thing I love is what was fun is that it's, different people I think about things in different ways, which is amazing because I went with wind power and my first thought was I'm going to put lots of gears on it. And then I did this, and this is like a very different approach. It's like, let's use the crank mechanism and the stories, like this is something where it's the spinning is straight on. And this spinning is taking it and making it
so beautiful.
sideways.
Yeah. I had so much fun doing this, and I just put outside because I love to see it move.
Yeah.
Maybe because it's so hot here in Brasilia, so it's really reassuring. There is some wind, actually.
Yes.
It's moving.
It is.
First version in my backyard, not my backyard, in my balcony in Jerusalem. Nothing, no wind.
No, it's awesome. And then you can show projects like you can put a motor and use a battery, but you can also do the same using the wind, right? So you can, or solar power, right? That's like, that would be awesome. Just like to.
That's the beauty of it.
Yeah.
Yeah.
Nice.
Yeah. So, I mean, and I think what's fun too is like, again, we're making things out of, paper and simple materials, but like, when I proposed the workshop, you all came back with, like the boy who harnessed the wind. And it's like, wind can be used to make electricity and to do so many things.
Yes.
This movie is amazing. It's inspiring.
Thank you, Jasmine, for so many beautiful things. Thank you so much. Love it.
Yeah, so I thought next I was going to go, I mean, people should feel free to start tinkering at their own pace, but for anybody who kind of needs a starting point, I was going to walk through like how at least, again, there's no right way, wrong way to do this, but how I built the base and like attach the pinwheel and all that.
Awesome. I'm tinkering along.
I'm tinkering already.
Everybody here and on YouTube, I hope. So
I hope. Okay, guys.
Look, so
time to.
You see, I have mine ready here.
I already cut my wheels.
Okay.
In paper, in cardboard.
I just have to go and get something, but I come back. I'm here, Jasmine.
Okay.
I think I'm going to do my pinwheel with this material. It's a kind of plastic that came with my ice cream pack yesterday. So I thought maybe I should try this. I don't know if it's too hard, but I'm going to try to use it instead of paper.
Try.
That's cool. Yeah. I've been using, so I used cardstock for some, and then I also made some with origami paper. So yeah, just anything that's bendable. So the way I did it, and again, it's interesting because if you go onto the Exploratorium website, they have other methods where like they make one out of a paper cup and
yes, that was amazing too.
Yeah, I didn't have any paper cups though, so I just made it.
Me neither, so I have to try this.
I said, no way, I'm gonna buy paper cups to do this. Just like use paper.
I mean, I felt bad because I'm like, the whole point is green energy, and I bought a fan because I ran out of breath testing everything. That's the most green.
Okay, guys, it's hands-on time. We are here at Maker Day. Jasmine walk us through some mechanism, and you are going to make something with the materials that you have at home, at hand, and we are going to do together here with Jasmine. We can ask her questions, show her what we are doing to see if it's okay. So we invite you here at Zoom and at YouTube to join us for this tinkering with wind.
Yeah, and definitely just ask any questions if anything I'm explaining isn't clear, or if you just have a different approach to doing it, like please share, because like I said, there's no right or wrong way to do this, and it's always really like at least to me, I find it fascinating to see how other people do things, because I'm like, wow, I would have never thought of that.
Oh, I love this too. When somebody come with an amazing idea, different ideas, they say, oh, I haven't thought of that. This is good. This is
That's
awesome.
how I felt when I found the exploratorium one. I'm like,
yeah.
I never even thought to like make it with a crank mechanism.
Or using a paper cup.
Oh yeah, or the
paper cup.
I mean, I was trying all kinds of things to just. So yeah, so for the pinwheel part's pretty simple. It's just a square sheet of paper, and I just like, you know, draw 2 diagonal lines so I can find out where the center is. I'm cheating, and I pre set some of these. Let me actually let me just explain this real quick, and then I'll answer Gary's question.
Okay.
It's a very good question, because I ran into that problem as well, which like you think I would have remembered from school, but whoops. So yeah, so then for the pinwheel, you just kind of cut to about halfway. Whoops, here you can see it better where I have the lines there. You cut about halfway, and then there's a couple different options. Like basically the goal is to get this shape where you've got all the things in the center. So you can glue it or tape it. I actually preferred not to, because I hate waiting for the glue to dry. And so what I did instead is I tried a couple different things. Is one, I used, let me just show this. I used these like brads, I think they're called. And what I did is I cut little slits in the pinwheel. I can take this apart to show you, and use that to hold the whole thing together. So
nice.
I've got one leg of it still sticking out, and I'm going to use that later to attach it to the skewer. But here, if I take this apart, you can see that the way this went together is just no tape or anything. It's just little cutouts there for the brad that just goes right in there.
Yeah.
And then if you don't have brads, the other thing I tried was doing it with like just a hair clip, like a bobby pin. And so this, again, similar, I think this one I taped this down first, and then I put a hole through it, and then I put the hairpin through and put a little piece of skewer to hold it in place. And again, it's nice because you have this whole part sticking out, which makes it really easy later, because you're going to have to, you know, attach the whole thing to a skewer. And so if you've got the hair clip or the back of the brad sticking out, then you just.
I'm using a sewing pin.
Oh, I didn't even think of that. Probably because I don't sew. That makes a lot of sense. So yeah, if people want to start on that, and then again, you literally just take the whole thing and tape it right to the, you just tape it right to the skewer there. And then you've got the pinwheel attached to something. And I put a little piece of cardboard in the back there to make it a little stiffer, but you don't need that. So going back to Gary's question, while people are making pinwheels.
Okay, what Gary is asking?
Right, so Gary's asking, I don't always get my gears to mesh properly. What is your method to make sure gears mesh? And
wow, that's a big problem with gears, right? When we don't have laser cutters, I feel your pain, Gary.
Yeah. Oh, yay!
Yay! It works.
Oh, I like that plasticky material. It's like all shiny.
Yeah, it's a lid on an ice cream tin. It came covering the ice cream tin.
Oh my gosh. Oh, I thought that was a giant pinwheel, and they're really, oh, it is really big actually.
Yeah.
So yeah, let me share my screen again. So I went through this real fast, but so generally when you have meshing teeth, even with like regular gears, the number needs to be something divisible by each other. So like 20 can go into 40, 8 can be divided by, both of them can be divided by 4. But the other thing is, at least for these like ones that I've made out of these skewers. So even if you have the same number, you want this gray circle here has to be roughly the same diameter. Oh.
Yeah. Pedro has just shared here website to generate gears. I hope they, so I suppose
helps
they
to calculate the
gear ratio.
Yeah.
Yeah. And so even if you're doing, so that will help you, because if you, for instance, decide, let's say you have something and you want it to move, you've got the pinwheel, and again, it's moving really fast, but you don't want something to be moving that fast. You can make a bigger gear with more teeth, and that one will move slower. And so for that, it's really useful to know the gear ratio. If you're going to even just have two gears with the same number of teeth, let's say you're using it like I said, for the bicycle, everything's moving at the same speed, but I wanted multiple things moving at once. So for the pegs, you need, you can kind of tell here, you need the pegs to come out and just hit the skewers going the other way just enough to actually like move them. And so the way I did is I measured out, I don't know if you can tell from the pictures here. Oh, you kind of can actually. So you can see I measured out this inner circle where the pegs are on. And that is actually around the same diameter, just a little as this one. So that big circle there. Wish I had these in person, but oh well, they're on the bicycle now. No, I'm trying to do some live drawing here.
No, but I think we get it. Okay.
Yeah, so like this is basically, this diameter here is roughly the same as this one. It's a little bit bigger because it needs to overlap into there to actually hit the pegs, but that's kind of where you need to be. And yeah, just experimenting also. Like I said, the very first one I made, these ones, they, you know, I think I measured them out and I still didn't measure them right. And oh, you can't see in that video, probably because I cut the parts where I kept getting stuck, but I should have, like, they did keep getting stuck. The gears didn't always mesh. Yeah, so yeah, so that's the gears. And then I guess where are people at right now? I don't know if
oh, you can ask people to show what they are doing now here in Zoom.
And
so
they can open the camera.
Yeah.
Ooh.
So look at Kat. Yeah.
Yeah. Oh, that's such a pretty paper.
Yes. Beautiful since the beginning.
Cool.
Awesome, Kat.
It's weird. I don't think I'm seeing everybody in the Zoom room. It's showing 27. Okay, I guess a lot of people just have the camera off.
Yeah. Let's take a look what Pedro is doing. Yes, Pedro. What are you up to?
I just have to answer the door over there. I can show you. I'm still making the pinwheel here.
Okay.
All right. So just a second.
All right. Okay.
Oh, whoops. I think some participants also don't have the link for the camera. I think I had the webinar link and then the participant link.
I see. Oh, not everybody. Sorry. Yeah. Oh, but please put in the Padlet so we can take a look. So you can see you tinkering along. Can you put here, Sora, the link to the Padlet? Yes. Where we are uploading what we are making.
Cool. So yeah, so I'll keep going on to the base as well. Again, like this is just what worked for me. There's, you know, even you could see the Exploratorium was making the base in a different way. I made mine out of mostly just like these triangles out of cardboard. And so there's a couple different ways, like, you know, this one here can actually show us. So you can do sort of just a sheet of cardboard that you literally just like fold in half, and then you can like either glue something across to hold it in place, or you can even, this one is just, the bottom is just taped to hold it in place. Or the other thing you can do if you have a long enough piece of cardboard is you just do into 3 parts and then you just tape the top and that'll hold itself in place. So that's how I've been making the base for this. You can see just
okay, so I guess I need some cardboard now, huh? Does everybody have some
you can also
cardboard?
make it out of paper too, like the exploratorium.
That's true.
Paper.
True. No. Oh, Eco has the awesome. I just regular paper he used.
Let's see, Ico.
I'm trying to make, since I have only the regular paper, I'm drawing on mine, so it makes a little prettier when it
Mechanism.
Pattern paper.
So
You see, you can clearly see where he is in the STEAM acronym, right?
Yeah.
Forget the mechanism. Let's do the
A for art.
first.
Yeah.
Awesome, love it.
And I just to remind everyone that's watching us on YouTube, please show us your project as well. Submitting a photo at our Padlet, all right?
And
gonna
I'm
get some
also going
cardboard.
to share the Google slide link because I got a question from Celia about the links and stuff. So let me copy that.
Okay, we can share YouTube as well.
And there's some, I'll get to at the end, there's also a couple links.
Okay.
So yeah, right. So going back to this, what I did is, so I actually, I literally just used like a hole. So I measured where the center of the cardboard is. And then in terms of like where the pinwheel goes, a couple of things that I, again, learned the hard way, which is if you put the pinwheel too low, it will hit the table while it's spinning.
Oh,
Which is why this poor frog always sits like on the edge of the table.
this is a good tip.
Yeah, like we do, we poke everything, we place everything, and we go, oh no.
Oh no! Oh no!
Because it's so obvious once you
Oh,
do
no.
it, but you don't.
Yes, like.
And then
Yeah.
the flip side though is if you go too high up, then the axle just doesn't have as much of a contact point, and so when it's spinning, it'll be a little bit more wobbly. So just something to keep in mind, and you can play around with it. But yeah, basically you just make 2 holes. I marked this one and I didn't put it in yet, but and then you can either put the skewer in directly. If you do that, you'll need some kind of like stopper here, because otherwise, as I again discovered the hard way, if you blow on it, it'll keep moving forward, and then eventually the pinwheel will get stuck because it's going to hit the base, which
Oh. The same thing happened in the afternoon session when we use DC motors, and sometimes we stick something on the tip of the DC motor very close to the base, and the DC doesn't turn. So you have to keep in mind to be careful where you attach a piece to the end of the DC motor.
And I didn't even notice at first. I was just like, am I not blowing hard enough? And
It's not working.
I realized,
Why it's not working?
I love it. It's so good. Like this playful way of looking at mistakes. This is the best for me, really.
This is,
It's
yes.
awesome. Yeah.
the other thing is like you can sketch.
I do like troubleshooting when we are
Yeah.
trying something. I do like the mystery of figuring out why it's not
Like, it's-
working.
No, it's really
At first, it
positive,
used to
right?
get me frustrated, but now I do love it because it's a mystery that
But
you have to
even
figure
so,
it out. you know?
Even when we get super frustrated, because then
Yeah.
we have emotion, and emotion is awesome for learning. We get so frustrated, and
is.
then finally we get it. So just satisfaction of getting things, you know?
Yeah, I like
after
it.
some effort, just like it's awesome. I think that's
I think
that's
also just
the best way to
remembering
learn.
that like failure is part of the process.
Yes, of the learning process, you know?
Yeah, if you don't fail, you know, either you're, I don't know, a miracle worker, or you're probably not, you know, trying things.
Who doesn't fail?
Who's not trying things that are easy enough.
Yeah.
So this one I just put like a little cardboard stopper on there. The other thing that you can do is you can actually just wrap tape on there big enough so it doesn't go through the hole. And the other thing you can try, again, I just experimented with lots of different ways. So this one I have the skewer going straight through.
I'm working on my base right now.
Oh, nice. Oh, I like
Yes.
how it's a tall one too, so you won't have the problem I did where the pinwheel runs into the table. So this one I tried putting a straw through as well, so the skewer goes into the straw. And the main reason was just they both work. With the skewer straight into the cardboard, sometimes I accidentally made the hole too big, and then the skewer would just be a lot more wobbly. So with the straw, it's just a little bit less wobbly, but if you don't have a straw or you don't feel like it, you don't need it. So it's just, oh, and the other nice thing about the straw is it kind of acts as a stopper. So again, I put tape on there, so this can't go too far back. Because
I see. Yeah, otherwise when the wind blows, it might get stuck there, right? Because it just gets crushed.
Well, I'll bet you could probably put like a piece of cardboard on the back of the pinwheel and then it'll get stuck. But I think I did this because I also wanted this at a very specific distance, because if the pinwheel moved in, then the circle moved out and the frog is sort of mounted at a specific point. So then his leg would be like out here and he would be there. But yeah, I mean, I'd say just experiment. The main things you need are basically just a pinwheel, an axle, and then something that you're attaching to the pinwheel. So yeah, so I guess I'm gonna start tinkering too now, and I'll
please
see my really messy table there, my notes on what I was going to talk about. Oh yeah, and then I guess when we have, so I think we've got another half hour, so we'll tinker for a bit, and I'll ask people to share things, and then the last few minutes also just talk about, actually no, you know what, I'm going to talk about this right now because it's useful inspiration while you guys are tinkering. So again,
okay.
Yeah, you don't need to totally pay attention, but just some more inspiration. Whoops. Share screen.
Is everybody working? How are you guys at YouTube?
Yes,
How are
I'm
you
back.
doing?
I'm back.
Yes,
Awesome.
that's
A little
good.
bit late. I'm still doing the pinwheel.
Okay. I finished
Jasmine,
my pinwheel and I'm working on my base right now. Already painted?
Of course, that I made the mistake that Jasmine told me not to make. It's too big,
you guys
so
way
it
from
keeps
ahead.
bumping.
It's okay, you just put it over the end of the table and just pretend.
Yes, that's
design all
pretend
along.
that was the This is intentional design.
So yeah, just I mentioned already the Exploratorium website has just brilliant inspiration there. A couple other things that are useful. There's a lot of makers. So I pulled out Rob Ives in particular because he does a lot of automata. But the thing is, like, again, just think of, if you think of the pinwheel as just a motor, like you can attach a pinwheel to that and make that bunny, and you're gonna have that bunny spinning.
Yeah, I want the bunny. It's so cute.
So he's got all kinds of amazing stuff on his website.
Yeah, I follow him. It's amazing.
I know, I used one of his dinosaurs as a model for something. But I guess just looking at automata for inspiration as well, because like anything that's got this sort of crank motion is something that can then be adapted to wind power, and then
Yes.
yeah. So like I don't know. There's like the frog is basically an automata anyway. It's just I used a pinwheel instead of like turning it by hand. And the other one that I saw, which I thought was really cool. So I think Lindsay, who I don't know if she's on the call right now, but developed this, and then Sam on Twitter made this. And this is just another really cool way to make a pinwheel entirely out of straws instead of paper. So I thought that was really neat. So yeah. And I'm going to also make some stuff. Oh, wait, no, I want to see what people are making on Padlet first.
Let me see if there is anything at our Padlet.
Take a look, Sora.
Yeah. Oh, we already have the eco spin wheel at Padlet.
I'm too busy to put pictures. I'm just trying to, but I will.
It looks like patterned paper almost.
Yeah.
And then I guess people who are on the call and can share a camera, like Aparna, I don't know if you were tinkering early in the call. Oh, Pedro's got something also going on. Oh, that's a really nice color paper.
Aparna, yes. Let us see, Aparna, please. Yes, unmute. What you do? Oh, yeah.
Can you
she
hear
has
me?
the face.
It's
Yes, yes.
I use some old fan. I think I hope it works.
Uh-huh.
Oh, that's awesome.
Yeah, I'm just working. I don't know.
I mean,
Yeah.
that's how I'm really like, I don't know what I'm doing half the time.
And I'm using straw, so I think it will move so easily. So in
Uh-huh.
this hole, I will add this straw. So you know there will be less friction.
Yeah.
Yeah.
And I like that you have two holes there, so you can already
Yeah,
imagine
yeah.
you're going to be doing
Yeah.
like multiple
But
things moving.
Yeah, then I will add some straw here. So hopefully it works.
It will, it
Wow.
will. Keep working, Apple.
Thank you.
Well, it's finished when it's finished, right? It will work
Yes.
eventually. If it doesn't, it's because it's not finished yet.
Cool.
I
Oh,
think
yeah,
it's
I
okay.
see. I think I have panelists and attendees, and so I think maybe attendees can't share camera.
I think so.
Okay. Oops. Okay, I'm sorry about that, everyone. Yeah, still learning how this all works. But yeah, if you share on Padlet, I'm also keeping an eye on that.
Yeah. The panelists can share.
Cool.
If you want, I can share you something if you want something like this.
Oh my gosh, what is that?
Oh,
A seahorse. I love it.
Yeah.
Oh
it's
no.
there.
what is
And
this,
if you move this
Apple?
one, it will open its mouth.
Oh my gosh, this is so
But I
cute.
really want to add some gears here. Actually, I'm looking for you, Jasmine. You will teach me something. I don't have mechanical engineering background, so I tried it, but I think it is not really successful. It
You
was.
can use
It
the
looks.
cam for it. So one of the other links that I was going to share later is the Paper Mech website.
Oh, this is so precious.
And
I love
I have
this.
this one as well. It is very simple. It's you just have to move, and it's just made up of paper. It's nothing.
This is
So
awesome.
cute.
And I have something like this. Pac-Man. Maybe you remember this one.
Oh my gosh, this is gonna be so beautiful when you put the wind power.
Yeah, and
there. Yeah.
Whoa.
yeah, like this you can move it.
I
So,
love this.
Thank you.
Thank you. I love it.
That's
Oh,
amazing.
You're welcome.
I mean, you say it's just paper, but I think it's so much, I think it's difficult to try and figure out how you can make complicated things out of paper, right? Like,
Yeah, but I really miss I really can't understand the gear and how to move it. I really loved it when you showed how the diameter we have to measure, because I really don't have that idea. And
Awesome.
I will try it maybe. Right now I'm doing this, but I think I will add some solar panel. So this will move and then everything will move, something like that. But I think it will take a lot of time.
I mean,
Before that, I should learn about gears.
I should learn about solar panels. I haven't really gotten to work with them much. Like,
It's so nice.
Maybe I have this picture if I stop the video, and I think one of them is working on a solar. So my picture, yeah, I make a small robot. It's just a motor robot, nothing else. It's just for the kids. And especially for nephews.
it fits with the whole green energy. Yeah.
Yeah.
Oh yeah, I can. The Paper Mech website, I'll put that in the chat as well. So that's a good resource. I mean, that's mostly if you have a laser cutter, because it's kind of hard. Part of the reason I made the gears the way I did is because cutting gears from scratch is really hard.
I don't have that machine, so that's why I have to do everything with hand.
One thing you can look at, and that would also work actually for wind power, I'm going to share my screen again, is I didn't do this, but actually now that I think about it, this would be a cool thing to do with a windmill, is, where is the bill?
I love this website.
So up and down crank, which like that's something you can all cut by hand, and that again just uses a spinning motion. I mean, it'd go a lot faster because it's on a pinwheel. So you have like something going real fast. And then the other thing, actually, for something like the dinosaur, is a cam. And so a cam creates sort of a up and down motion like this. And again, you know, it's something this you can cut without a laser cutter, which is nice.
But it will take a lot of time, and especially with your students. Oh my God, you have to work day and night.
That's true. Yeah, I have only like I work with students more like as a tutor, so it's one-on-one with Zoom, and like if it was a whole class, it would be quite difficult to explain. Oh, maybe change the audience to everyone instead of hosts and stuff. Oh, yes, I did do that in fact.
Awesome, Sora. This is awesome, like to teach the kids so that they can decorate the garden right now that we should be outdoors more instead of back in classrooms wearing masks. And I want to show something that I did with solar power. You guys were talking about solar power. Okay. It's like it's laser cut because I had something that was laser cut here. So I just used what I had, but it could be anything. So on the top, I have a very a DC motor, a small one, and I cut a ballerina here. So it spins. So my project for tomorrow is to make a big one of those so that I can bring to the kids so that they can, you know, get inspired and do their own. But yeah.
That's so beautiful.
I still have to get the solar power I bought online, so I still don't have it, but I want to hook them tomorrow.
I saw that one on Twitter and I was just like, it looks like, what do you call it? Those music boxes where you open it up.
Yeah, cute. Yeah, I could put some music too, right? So it would spin to different tunes. Awesome, love it. Okay, I have my my mechanism going. I just don't know what is going, who I have to still to make my character who is going to be spinning, but it's moving. Yeah, so I don't know it's gonna be a dragon or just a circle. I don't know.
I'm going to vote for dragon, but you know.
Okay, guys, if anybody here, the panelists who are here and wants to open the camera and share with us what you're doing, please do so.
Yes, please do so.
Hey, Jasmine, I'm a little bit late here, doing the pinwheel, and I was thinking like, I was a little bit tricky to connect it to the stick. So I'm hitting some hot glue to stick it here, but I was wondering if it's heavy, we will spin good. How will be the movement? Like, it's better to be light?
If it's heavy, now we get into physics. If it's heavy, it's going to be harder to get it to start moving. But then once it moves, it's actually going to have more momentum, and so it'll like keep moving for longer sometimes. But yeah, you might need to like, it might be harder to get it to start moving. So you might need to either blow really hard or like get a fan or something.
Makes sense. All right, let's get to it.
Yeah, it's moving. Maybe you can see.
Ooh.
Awesome. Oh, Sara has her base going too. Awesome. Go get a fan, sister. You're gonna run out of breath.
So excited.
Yeah, very exciting. I love it. Everything that moves makes me smile, you know, like just little projects that move. I love it.
Right? It feels so magical when things start to move.
Yeah, yeah.
Maybe I think that's part of why I became a mechanical engineer, not like something else, because I just like making things that move.
Jasmine, I'm a little bit confused is how it works with like
Oh, it just
mechanism. I don't remember how it works.
Oh, for the gears meshing?
Yeah.
Yeah.
If you have the gears, you still use you can still use the pinwheel, right?
Yeah.
Yes.
Let me I'll show the picture again because I don't have it with me in person, but you can see what is going on here is the pinwheel is attached to the middle gear there. And so that's what's actually the only one that's actually spinning from the wind power. And then the other two are moving because they're pushed by that gear. Actually, it's a little more obvious in the video.
Okay, it's in the
there
middle.
you can see the middle one is moving and it's pushing the other.
The small middle one. Okay.
Yeah.
Okay, thank you very much.
No problem.
So
it's more complicated.
you don't have to do 3 gears. I just did, 3 because I was feeling ambitious. But I mean, this
exploring. You were exploring. That's right.
This one is just 2 gears right there. And so it's just one pushing the other one, and you can kind of see how like actually there it's a little bit slower the video where the tips of the gears are just enough to touch and mesh without like catching on each other.
Cool. Thank you.
Super cool.
Thank you. Yeah, it's fun playing with gears. Cecilia says she's getting lightheaded from all the blowing, which is why I bought the fan. Very funny when we went to the store and they were like trying to tell me, oh, this fan is, really high powered. It'll keep you really cool. I'm like, no, that's not what I need it for. I just need it to like blow this pinwheel for me.
People are like, what?
Oh yeah, okay, so just for a time check, we have 20 more minutes. So I thought we'd just spend most of that tinkering. I did have a couple links at the end I was just gonna share for more resources, but if people have questions, just throw them at me. I can.
Any questions from here? Any questions from YouTube? You guys at YouTube, you can also ask questions, okay? Just write it down on the chat box. And Jasmine can answer those questions.
I just need to open up there we go,
yeah.
YouTube chat.
I already have my base.
Oops, slide 18 video access. Is there a way to just share all the videos at once? Okay. Well, if you just click and request access, I'll just
Maybe later on you can put some of the videos in our palette so people can refer back.
Yeah.
Oh, that's so smart. You'd think I would have after like this much time, you know, figure all this out.
Yeah. And your website too, so people can reach you and see all the awesome projects. I have made once the Ticklebot, and I loved the experience. I still have it.
Yeah, I bought the servo to try the Ticklebot project,
Oh,
but
so
I
cute.
just lost the servo.
Oh my
Oh,
gosh.
I don't know where it is, you know?
Okay, but when it comes to servo motors, these hobby ones, you should get at least 2 or 3, not only one.
I actually, when I started with the Ticklebot, I only had a couple, and I kept having to take apart all my old robots to get the servos out. And I was like, okay, I can't, it breaks my heart every time I have to take them apart. So I bought one.
Yeah.
Yeah, they become like your little pets, right?
Yeah.
Oh, this one.
Maybe the pandemics or something, but I see my little projects as my friends.
I'm
Gary's
I'm
saying
trying
that he-
here
Okay.
to do some. I have this little fan, which is a
Mhm.
USB fan,
Yeah.
so it works very badly. But I have
Oh.
a little bit of a trouble that I'll try to get on my own. But the wind from the fan is actually pushing the stick, the skewer into the little cardboard box I have.
Yeah, you know what you could do? Put like a little piece of straw, something like a
Yeah,
stopper.
so it goes on itself, right?
Yeah, so yeah.
But I'm really glad that it's actually working anyway. So
Yes. We
I
have
was
a
not
question
feeling
from.
that confident.
It is working. Awesome. Gary saying, Jasmine, that he has a table full of Tickleботts and that they are addicting.
Oh, that's awesome. I'd love to see a photo.
Oh, please take a photo and put in the Padlet so you can inspire Gary, other people.
And we have a question from YouTube as well.
Okay, and then I have one from Abraão. But
okay, yeah. Larissa is asking Jasmine if if I intend to make a bigger model, do I have to make a bigger pinwheel? And which materials would be the best in order to keep it outside?
Outdoors, yeah.
Outdoors.
So yeah. Those are all good questions. And I haven't experimented with that, so I can tell you what my like intuition is, but you'll definitely need to play with it. So first of all, the smaller the pinwheel is, like the less wind it's catching. And so it'll be easier to spin, but it won't have as much force. And so if you're going to be doing something that like that is bigger and heavier, it'll probably need a bigger pinwheel. And it might even need a stiffer material to move. So like some of the whirly gigs, for instance, they're actually using like wood as a material, and probably need a fair amount of wind. But I mean, it also depends, like if you've got, so a lot of the forces are also coming from like the friction in here. And so, you know, you can have something big that if you manage to reduce the friction quite a bit, it might still be fine. So I would just experiment and see. And then in terms of materials, so if you're outdoors, definitely not use paper unless you're living somewhere where it doesn't get wet very often. So
Brasilia.
Like,
if you're here,
right, the plastic cover off the ice cream.
Oh, Israel.
Yeah. Except there's no wind in Israel, apparently, except at night when I'm freezing. But I would you could try making the pinwheel out of like something plasticky, for instance. Like, you know, if you just save the packaging from something, there's always like plastic packaging type stuff. And you can try cutting that up and making a pinwheel, or even like laminating the paper to keep it sturdier. So yeah, I mean, I don't know if you could give more detail, it could probably help, but I would just say experiment around and definitely Google whirly gigs. That's what it's called when people like make things with the pinwheels, and you'll see that people have made all kinds of things. I think a lot of it is out of wood, but I think you don't have to do wood. Oh gosh, we only have like a few minutes, or no, we have like 12 minutes left.
Jasmine,
no
did
pressure.
you answer Celia's questions at Q&A?
Oh, let me. Oh, the Google slide link.
Yes.
I put that in the chat.
Okay.
Yeah, and if any, I think you might need to send me a request for the video, but it goes to my email, so I'll just grant access to everybody. I'm sorry, like you'd think I would know how to do all this, but I still get confused. And I'll put the videos on the Padlet afterwards.
Yeah, you just have to open the access, and for anyone with the link. And then it will
Yeah.
go.
It's
So you
weird
don't
because
have
it
to-
shares the slides with everybody, but then the videos, I think because they're in Google Drive, it's not automatically sharing them.
No, you have to share the video as well.
Oh,
Like
the
no, but
one
you
they
can put in
don't
the
play.
set. You can make it like anybody with the link can access, and then you embed in the slide, and then it works fine.
Cool.
Okay, I have the pinwheel at one side and the wheel working on the other side. So now I have to figure it out what.
What is gonna move? Yes.
Yes.
So you have only 10 minutes, no pressure or anything.
And that's what other people are doing.
Oh, come on.
We are in the same boat,
Comfortable
Soraya. We
sharing
are in the same boat.
Come on, director. Come on. 10 more minutes, please.
10 more minutes, teacher.
10 more minutes, please.
Yeah, if people feel comfortable sharing their camera, I'd love to see what you're doing. I might pick on you though to explain.
Oh, I'd love that too. What are you doing, guys? Sarah, Iko, Apu, what are
I
you
like how
doing?
Cecilia is using a box as the
Oh, that's
wait, can you show that again on the camera?
Sure. So this is a little guy that I have from before. So I'm thinking I'm gonna make make him move. So I'm transforming this into a automata.
Oh.
so cute.
I measured wrong. So I
Oh,
have to...
this is so cute, your frog. No, I want to see your frog. Forget the box. Forget the box. Oh, this is so cute.
Isn't it? Who has a hat and everything, totally articulated. Love it. So many
Make him
possibilities.
dance.
Yeah, he can dance. Yes.
What are
He's
you
going to
using
make
for
it
the
dance.
for the joints? Are those also like brads or?
Yeah, they're brads. They're just
Oh.
tiny ones.
Oh, we don't have those tiny ones here in Brazil. It's a pity.
You can order
Amazon. So
Yeah.
I'm kind of digging the whole frog thing too. Actually, I think I was
Yes.
inspired to make a frog from your earlier frog. So now we're just like in this
Frog movement.
they're just so
Here,
much fun to
Soraya.
draw.
It's the frog zeitgeist, right? Like everybody's thinking about
Yeah.
Here we have those arrebites that you can hammer it. The small ones you can punch, you can punch with a hammer, and also
Yeah.
works. Yes, we have the small arrebites. I don't know how to say. I think it's the same word in English. I don't know.
I don't know the name in English.
Like those metal pins that you can throw it to the other side and you punch with pressure.
Oh,
Actually-
ribbits.
Ribbits. Yes.
talking about frogs, right? Ribbits.
Ribbit.
Someone had to do the joke. Sorry.
Nico, you're terrible.
I like
I'll take
it.
that as a compliment. Thank you.
I see Catherine is still doing gears. Oh, that'll be
I don't
fun.
know.
I'm such a sucker for gear, so. I guess
I'm struggling.
Oh no. I mean, like I said, my first one like came out and I was just like, oh wait, these keep like catching on each other. Oh, that looks.
Wow, but it's almost
Yeah.
there, Kat.
Yeah,
Almost.
almost.
Not yet. Not
Guys,
yet.
you're rocking. You're rocking.
I was too afraid to try. So
No, I never afraid to try, you know. I don't know if I can make it, but I'm never afraid to try.
Fail early and often is
Yeah.
what I heard. So I guess just because there's 5 minutes left, I think a lot of people already know about these resources, but just for anybody who doesn't, I'm gonna share again. So a lot of just general maker resources and stuff that I like looking at, and there's so many, so I didn't even, these were just the ones that came to my head first, was just generally like Instructables and Makescene have a lot of stuff for free projects, and sometimes I'll just, if I'm like, I'll just look at them for inspiration to see like what are other people up to and stuff, and you know, a lot of people just post amazing things. For mechanisms in particular, so I already put the paper mech one in the chat. 507 movements is really cool. It's actually based off a book that's, I don't know, it's several centuries old. And it has all these different mechanisms. And it's just fun to look at, like, for inspiration on how you can make things move. They have a whole section on gears and stuff as well. And like, again, for me, I find it a fun challenge to figure out like all these gears, you know, back in the, they're usually made of metal and stuff, but I like figuring out the challenge of like, how can you actually make them out of cardboard or whatever materials you have at home. Then for like electronics and computing, I think a lot of people already know the microbit, but I use the microbit for a lot of things. And there's a few other similar ones. There's also the
I love microbit.
Yeah, and they have also on their website like so much stuff. So they've got a lot of like intro projects, and then if you just search for microbit projects, you'll find Scrappy Circuits, which I haven't, and my book is sitting waiting for me in Florida. I'm so excited for it. But the website as well just has inspiration for how you can like do electronics, like very low cost, not needing any kind of really specialized equipment, which is always fun. And then I have on my website, I think some people already, I showed at the beginning, but I went through pretty fast. So some of these, at least, I do have instructions for. So a lot of these are based with, made with a microbit. But if you just want like some projects, like I've been really lucky and people have been sponsoring me to actually document these, which is great because then I can make everybody or give them to everybody else for free. So yeah, so those are all just some great resources. Also, for those of you not on Twitter, or for those of you new to Twitter, there's a lot of people on Twitter all just doing amazing things, and that's how I've met a lot of people here. And just seeing what they're up to is always fun, and people will always post like different, you know, projects for inspiration or different like building challenges and stuff. So yeah.
Thank you, Jasmine. Awesome tips and links.
Yeah,
keep us tinkering for a while.
And thank you to you, like, for helping keep the conversation going, because just me on my own, I'd be like,
I just got inspired by Cecilia because she used a piece of paper and 2 straws to make a cranking mechanism. I don't have any wire, so I use the mechanism that Cecilia is using with her automata, you know.
Awesome.
A square of cardboard and 2 pieces of skewers.
That's great. Wow, and you could also use that, you know, if you wanted to do something not wind powered, you could use that as a handle as well to like.
Yes, it's very sturdy. I put some hot glue in, and it's very sturdy, you know.
Ooh, oh, I'm starting to see things on the Padlet. Oh my gosh, what is this butterfly? It's beautiful.
Isn't it?
It doesn't actually show who made what, or it probably does, and I just don't know how to check it.
No, you have to put your name.
Larissa at YouTube, she just said that she was wondering and imagining and exhibit of all the productions, all these contraptions all together. This will be amazing.
Yeah, I mean, if people could keep posting to the Padlet, the other thing is, you know, maybe people can also share it on Twitter and tag it with, I think the Brazil Maker Day 2021, is that the?
Maker Day Brazil 2021. And also tag Jasmine.
Oh yeah, that'd be great, because then I get to see it.
And Thomas Maker, we would love to see the final product, okay?
Oh, and I think actually, because people were asking about doing things outside, it's hard to tell from the photo, but I think Tonya made one that is using like a plasticky material maybe instead of paper, that or it's just very shiny paper. But that's like a cool way to do it as well. Oh, and I'm seeing all the tickle bots. Oh.
Hello, mommy. They're saying
hello, mommy.
I like the BMO one. Yeah, I'm putting the tag in for the Twitter Maker Day. It's oh,
Bom dia, guardia fantástica. Estou pronta para a próxima aventura. Quer dizer, quase. Deixa eu ver. Uma desenhista, uma astronauta, professora de futebol, uma doutora do coração, ou todas em uma só.
We have an audio.
Escolher uma história, eu posso viver todas. Aqui, meu futuro é do tamanho da minha imaginação. One School é educação infantil dos 2 aos 5 anos.
O programa de tecnologia.
What's going on, guys?
É um dia que a Casa Thomas Jefferson abre as portas.
Alguém abriu a live e está com o áudio vazando para a gente. Isso é o começo da live.
Foi a Jasmine.
Para dentro do Makerspace.
Nosso tempo já deu.
Já deu. Our time is up? Really?
Yeah,
oh,
sorry.
Always like this. Every time we are having fun.
I need more time because I was suffering here.
Thank you, everybody, for thank you all for attending and for tinkering with me. Oh my gosh.
Jasmine, we guess that you have a video going on your
on the YouTube. Well, thank you to the people of the Zoom channel who can hear me, and Danny and Soraya, thank you so much for like helping, you know, keep things going and stuff, and just sharing what you're doing and making this a lot more fun.
Awesome, guys. Can everybody check if we okay, right, we got it. Okay, so we can say proper thank you, Jasmine, for having us, for teaching us all these amazing inspirational projects. And yeah, we're gonna keep tinkering and posting on Padlet. So the conversation has just started. Thank you so much. It was a pleasure.
Jasmine, thank you so much. We'd like to thank you as well, everybody that attended to those sessions, the 2 sessions today, the first one in the morning with Nathan and now with Jasmine. Thank you so much for joining us at YouTube or here at Zoom. You are awesome. Keep doing and keep sharing your projects with us. We'd love to see it, we and Jasmine. I put the link, our tags at the chat box on YouTube. I'm going to put the tag here at Zoom as well. Thank you so much. Thank you, the embassy, the United States Embassy in Brazil, for supporting us with Maker Day. The embassy is supporting all the 24 binational centers that are running activities and experiences with their community during this day. So check the program at Maker Day website. Thank you so much for our team to joining us here today on a Saturday. You are awesome, guys. Thank you. Without you, we can do nothing. Thank you, Wabi. Thank you, Sister Dani. Thank you, Vander. Hello, Vander.
Thank you, everybody. See you.
See you. Keep making, guys.
Thank you, Jasmine.
Thank you very much for the opportunity. Bye.